Alright, so let's look at this example. Table 11.13 right down here shows the distribution of various ethnic groups in the population of a particular state based on a decennial U.S. census. 5 years later, a random sample of 2,500 residents of the state was taken, with the results given in this new table, along with this probability that we had from the census year. We're going to test at the 1% level of significance whether there is sufficient evidence in the sample to conclude that the distribution of ethnic groups in this state 5 years after the census had changed from that in the census year. Okay, so let's start out with our null hypothesis. In the case of these chi-squared problems, our null is always going to be that the distribution that was from the previous census is valid. So the previous census distribution is valid, and then our alternate will be that the previous distribution is not valid. Alright, now just as we've done before, we need to look up our value for alpha. Alpha is 1%, but we're going to use our chi-squared table. So now before we go to that chi-squared table, let's note that we have 6 categories of ethnicity here. So our degrees of freedom is 5, one less than that. So we're going to look up 5 degrees of freedom at a level of significance of 0.01. So I'm going to pull up that table, and actually I think it's over here. Alright, so 5 degrees of freedom will be right there. 0.01 gives us 15.086. Okay, so 15.086. Now what we have to keep in mind is that chi-squared tests are always right-tailed. So when we consider our test statistic after we get it, if it's to the right of 15.086, we will reject the null hypothesis. Alright, now the hard part though, let's get our test statistic. And rather than typing out chi-squared, I'll just write it. Now, I cut and paste our formula right there. So we are now going to figure out that formula, but before we can, we need to make a new column to this table up here, and that column is going to be our expected frequency. Now to get our expected frequency, we had 2,500 residents that were in the sample. If the assumed distribution were true, then we will take our 0.743 and multiply it times the 2,500 residents, and that's how many we should expect to get. So we would expect, if we take 0.743 times 2,500, to get 1858. And then let's do the same thing for the black population. 0.216 times 2,500, we should get 540. 0.0112 or 0.012 times 2,500, we should get 30. Same thing for this one, since it's the exact same probability. 0.008 times 2,500 will give us 20, and 0.009 times 2,500 will give us 23. So there's our expected frequencies. Now we've got to use this formula to find chi-squared. So remember that that little sum symbol means we're going to add up each of our calculations for all 6 of these rows. Okay, so let's start with the observed value minus the expected value squared over the expected value for every single one of them. So using our first row, we're going to have this value squared, and then divided by the expected value, 1858. And then if we go on to our next row, we're going to have 538 minus 540 squared divided by our expected value, 540. And then the next row, we're going to have 32 minus 30 squared divided by, the 30, our expected value, except I can't type. And then if we go to our fourth row, we're going to have 42 minus 30 squared divided by our expected value of 30. And then our fifth row, 133 minus 20, quite a surge there, squared divided by the expected value of 20. And finally, 23 minus 23 squared divided by 23. All right, so now let's do each of those calculations in our calculator. All right, so when you put each one of these fractions into your calculator, for the first one you should get 8.5447. For the second one, 0.0074. For the third, 0.0167. For the fourth, 4.8. For the fifth, and this one's the one that's really changing things because we had this influx of Asians, 638.45, and then the last one, because of the 23 minus 23, we get 0. And if we add all that up, that's 651.8854. All right, now let's notice that 651.8854 is certainly to the right of the critical value 15.086, which means it's in the rejection region. So it is in the rejection region. We will reject the null. All right, so there is significant evidence to at alpha equal 0.01 to reject the null hypothesis. The previous census distribution is no longer, oops, you can't see that. Move this a little bit. Is no longer valid.